Hello and good day once again. In the last video, I've shown you how to create a decoder using Circuitverse. A decoder is an output device which is used to convert a binary output into a 7-segment display decimal. In this video, I'm going to show you an encoder. An encoder is like the converse of a decoder, where it is used on the input device. Since humans are used to typing input on a decimal device, we have to transform decimal into binary. What we are going to create at the end of this video is a simulation of an elevator keypad where we press the floor level and the floor level is displayed into decimal. So we will simulate a 7th floor elevator keypad where 0 is the ground floor. Now, the truth table of an encoder is shown in the following worksheet. For our input is from 0 to 7. The value 0, if the input is 0, the value is 0, 0, 0. If the input is 1, the value is 0, 0, 1. If the input is 2, we'll have 0, 1, 0 because that's the binary equivalent. If the input is 3, we'll have 0, 1, 1, also the binary equivalent, and so on and so forth. Now, if you look at it column by column, we can OR the inputs together using OR gates, no? Where the value is 1. For example, for A0, we'll have 1 or 3 or 5 or 7. For A1, we look at the column for A1 where we'll have 2 or 3 or 6 or 7. For A sub 2, we will have A4 or A5, A6 or A7. We can just convert this into OR gates. Now, without further ado, let us head over to our Circuitverse, where I have created uh, a blank circuit, which we will use to convert into an elevator keypad. So our first floor will be 0. Our second floor will be 1. Below ground, let's say we have 0 as below ground. Our second floor is 2. Our third floor is 3. Our fourth floor is 4. Our fifth floor, we have a fifth 0, 1, 2, 3, 4, 5. We have a sixth floor, and we will copy one more. This is sixth floor, and we will copy one more for our seventh floor. So 0 is our below ground. This is our seventh floor. I've copied this from a previous circuit. That's why it has previous labels, but kindly disregard them. Okay, what we will do is transfer it uh, into binary. Okay, the keypad is in decimal, will transform into binary. First, we already have the truth table transferred here. We know that A0 is 1 or 3 or 5 or 7. A1 is 2 or 3 or 5 or 6 or 7. And A2 is 2, 4, 5, 6, 7. Let's put some spaces. Okay. Now, we'll type in the lines. This will be the lines where we will tap our orbits. This will be the line for 3. This will be the line for 4, 5, 6, and we'll have 7. Okay. First, we will implement A0, which is the bottom gate. So we will need an OR gate, particularly a 4-input OR gate to accommodate the inputs 1, 3, 5, or 7. So we'll go to our gates and we'll pick an OR gate, okay, and we'll increase the bit size to 4, okay, and then we'll go to the output and we'll connect this to the output of the OR gate, and we'll call this, I'm sorry, we have made an unnecessary connection. We'll call this output A A0. Okay. Now, the first is 1. We'll make a connection to 1. This is 1. Okay. Followed by a 3. This is a 3. Okay. Make a connection to the 3. We'll connect the line first to so that it will be highlighted as blue. And then we'll connect this to 5. So this is our 5. Okay. We have the guy there from our truth table. This is our 5. And then finally, we'll connect this to 7. Row 7. We just finished the first input, or rather, first output. Let's create the second output. The second output is A1. Okay. For A1, we are guided by the truth table is 2, 3, 6, 7. So we'll get an OR gate. Particularly, we'll make it a 4 input OR gate. The input size is 4 because it's given to me 4. We'll connect the output. Okay. And the first connection is to a 2. There's a 2. So connect it there. Okay. The second connection is a 3. Here's a 3. Connect there. Okay. The next connection is a 6. Here's the 6. We connect it here. We are guided by the grid lines. We'll delete the unnecessary one. 2, 3, 2, 2, 3, 6, and the last connection is a 7. Okay. And then we'll have head over to our last output, which is our A2. And an OR gate. A final OR gate which has 3 inputs, or rather 4 inputs, and we'll connect it to the output A2. There's an extra connection. We'll do that again. Let's start from here. Yes, we have that now. The first is 4. We'll just click 4. Have it here. It's 4. Followed by a 5. So this is our 5. Okay. Followed by a 6. It's our 6. Followed by a 7. This is our 7. Okay. 7. Now let us test this. Okay. Let's click a 0. It's 0. Let's click a 1. It's 1. Let's click a 2. 0, 1, 0, which is 2. Let's click a 3. 0, 1, 1. Let's click a 4. 1, 0, 0. 5 is 1, 0, 1. 6 is 0, 1, 1, 0. And 7 is 1, 1, 1. So we have the correct encoder. This is called an encoder. It encodes from decimal into binary. Now, what we'll do is to connect to create a complete circuit. No? Okay, let's head over to our extra sheet. Let's save this first. It's now version 4. Save. Okay, in case we miss. Yes, we miss on version 3. But we have version 4. Anyway, there's no problem. Okay, we'll make a complete circuit in the input side of the elevator where we press a floor level and then it displays the floor level for us. Okay, can we copy this and let's copy this and let's copy these inputs, Control C, so that in our complete circuit we'll just have to paste them like that. This is our elevator keypad, and then over to the right we'll make our elevator display here. Whenever we press 0, we'll go to level 0. Press 1, we'll go to level. But before that, we will insert a decoder on our output side. So we'll include an input decoder. Now we have this. So we'll make the usual circuit. Okay, connect the top. Then we'll connect to the top right. We have done this before. Okay. And then we'll proceed over to our bottom right. And then our bottom middle. There's our bottom middle. There's our bottom left. We don't have an output yet because we don't have it. Now we'll also insert our encoder. Okay, we do a right click somewhere here and insert a sub circuit. We will need a 3-bit decoder. There it is. What we'll need to do is to now the arrangement are in reverse, so we'll have to do some adjustments. Okay, it's A0 is connected to S0. A1 there's no problem. We'll connect it directly to S1. S2 will connect it directly to S2. Okay. Now, we don't have the right order necessarily, but we can connect 0 to 0. When we press 0, I think the circuit is not yet complete. Okay, that's complete. And then we'll connect to 1, then we'll connect to 2. It's like our elevator keypad where we press the keys and it's displays in decimal. We connect to 4. Now it's starting to complete itself. Okay. And then we connect to 5. And then we connect to 6. And then finally we connect to 7. Okay. So we have that, no? So if you press 0, we go to the below ground. If you press 1, go that press 1. If you press 2, this is the second floor. And we press 3, the third floor. Press 4, it's a fourth floor. 5, 6, and 7. So we have a simulation of an elevator keypad where our input is in decimal and our output is also in decimal. But in between, there's an encoder which transforms the input to binary and a decoder which transforms the binary back to decimal. I hope you realize the point. No? In the next video, I'm going to show you addition and subtraction. We'll start with half adders and then full adders and then register adders. Thanks for watching and bye for now.